In this series so far, we've talked about what an employee attrition model is and how it's built. And we'll be going more in depth into this building process as we move along through the videos. But first, let's take a look at where all this is going. How is an employee attrition model actually used? There's generally three distinct types of things that organizations are looking to do with employee attrition models, and those three things are risk segmentation, forecasting, and policy evaluation. And for now, let's just focus on the first two of those applications. Now, we've already seen a few examples of what an employee attrition model can look like. At the very beginning, we looked at this simplified model with just two factors, tenure and age. And then when we reviewed the build process, we saw an example of a model with three factors, tenure, salary, and whether the employee had had a recent promotion, along with this indication that we could include as many factors as we desired in this model. So for this next example, let's imagine we have a model with four factors: tenure, age, job type, and location. And I haven't shown this equation, but you can picture what it would look like. It would look like this equation with tenure and age, just with two additional terms, one for job type and one for location. Now let's suppose we use this model to assign a turnover risk to our entire active headcount. And just so that we're able to visualize our entire workforce all at once on one page, let's imagine we have an organization with just 10 employees. And you can then extrapolate this to an organization with thousands or tens of thousands of employees. So here it is. This is our workforce of 10 people. And we've used our turnover model to assign a turnover risk to each of these 10 active employees. And you can see for each of these employees, we have their tenure, their age, their job type, and their location. And each of these four traits have been factored into the turnover risk. And what we can see here is that the lowest turnover risk in this workforce of 10 belongs to this individual who's 56 years old with 15 years of tenure. And this is consistent with what we know about tenure models generally, that the older the employee and the more tenure that employee has, the lower that employee's turnover risk. And again, sure enough, that employee has a turnover risk of just 1%. Another thing we see looking over these risks across these different employees is that with more factors in this model, we're able to get more differentiation between these employees in terms of turnover risk. So if we look at the example of employees 5 and 6, we can see these employees have the same tenure value and their age is roughly equal. One is 40, one is 41. Now, if our model had only included age and tenure, these employees would have roughly the same risk. But we have these other factors in this model. We have job type and location. These employees have the same job type. They're both in job C, but one of them is working in the south location and one is working in the north location. And if we then look at their turnover risk, we can see that employee 5 in the south location has a substantially higher turnover risk at 5% than employee 6 who's working in the north location. And since the only real difference between these two employees is their location, what we can infer from looking at this is that our turnover model assigns a higher risk to that south location. So the more predictors we have in our model, the more differentiation we can get in our risk. And getting this extra differentiation is very important if the main purpose of our model is risk segmentation. Risk segmentation is when we divide our employees into several groups based on their risk. So who are the highest risk employees, who are the lowest risk employees, and which employees fall somewhere in the middle. This allows us to take a holistic look across our entire workforce and know where our biggest pockets of risk are. And it also allows us to identify those specific high-value employees that we are most at risk of losing. So in this workforce of 10, we've used our model to identify three different risk groups. Our dark red is our high risk group, our medium red is our moderate risk group, and the light pink is our lowest risk group. Now, in addition to using this model for risk segmentation, we can also use it for forecasting. So forecasting is when we're not so much concerned with the specific risk of specific individual employees. We're more interested in top-level turnover rates. How many vacancies are we going to have across the entire organization or across specific critical skill sets? And what forecasting allows us to do, among other things, is start planning to fill in those gaps well ahead of time because we have some idea what those vacancies are going to be. So to generate forecasts, we just take the average risk score either across our entire workforce or across specific subgroups that we're particularly interested in predicting. So if we look across this entire workforce of 10 employees, we get an average turnover risk of 4.5%. So 4.5% is our forecast turnover rate across this entire workforce. And we can also take a look at forecasts for specific jobs. So if we look at job A only and average that turnover risk, we get a forecast turnover rate of 5.5% for job A. And for job B, it's just 2%. So that allows us to start differentiating between different jobs or different skill sets and knowing specifically which ones are going to be higher turnover and which ones are lower turnover. Now, just to return to what I hope will be one of the main takeaways of this whole video series, from what I've seen in the field, the priority in attrition modeling for most organizations is forecasting. This is the application most organizations are looking to use these models for. But because of the way that predictive modeling is generally taught, models are being built and tested for risk segmentation without a focus on making sure that the forecasts are accurate. So organizations are getting models that have been built and tested for the wrong purpose. And as a result, they're using these models for forecasting, but they're getting bad forecasts. Now there's this final application of predictive modeling, which is policy evaluation, and we'll be getting to that at the very end. But the main focus of the rest of these videos will be on this distinction between risk segmentation and forecasting, and how to make sure we're building a model that does what we really need that model to do.